The involute is not carved. That was the first thing I had to make them understand. Stand at a workbench and try to cut a gear tooth by hand. Try to file that precise, curving flank that allows two teeth to roll against each other without slipping, without binding, transferring force smoothly across the full arc of engagement, and you will fail. Not because your hands are unskilled, because the curve is not a shape you can chase with a file. It is a shape that emerges from motion, and motion is not something a hand can hold constant across 40 teeth, or 80, or 120. I had spent years understanding this before I ever arrived in Iron Ridge. I had spent the last several months making sure the people around me understood it too. The hobber generates the involute. That is its entire secret, and it is a secret so simple it feels like a trick. A hob is a cutter, a worm-shaped tool with gashes cut across its threads to form cutting edges, those edges hardened and ground to carry the exact tooth form you want to produce. Set the hob spinning, set the gear blank spinning beside it. Synchronize their rotation precisely so that for every fraction of a turn the blank advances, the hob advances by the corresponding fraction, as if they were already a pair of meshing gears, the hob the driver, the blank the driven. Then feed the hob slowly across the face of the blank. The chips flow, the teeth appear, not one at a time, the way a milling cutter produces them, index plunge, each tooth a separate operation, each one accumulating the error of the last, but all at once, generated continuously, the involute form emerging from the geometry of the synchronized motion itself. The machine thinks in motion. You don't carve the curve, the motion carves it for you. I said this to the team on the morning we finally laid out the full assembly plan, and Cho Yeong looked at me the way she sometimes did when she was deciding whether a thing I had said was profound or merely strange. You don't carve the curve, she repeated. The motion carves it for you. The machine thinks in motion. She turned back to the alignment drawing without further comment. That was how I knew she had understood it completely. The problem, of course, was the one we had met before in slightly different clothing. To hob gears accurately, the hob and the blank must turn in a fixed, precise ratio. The mechanism that enforces that ratio, the gear train connecting the hob spindle to the blank spindle, must itself be made of accurate gears. Change gears, we called them, interchangeable wheels that could be swapped in and out to set different ratios for different tooth counts. Without accurate change gears, the synchronization drifts, the hob and blank fall out of time with each other, the teeth come out uneven, the spacing irregular, the flanks malformed. To build the machine that makes good gears, we needed good gears. Cho Yeong was the one who said it aloud, in the flat voice she used when she was not complaining but simply naming a fact that deserved to be named. To build the machine that makes good gears, we need good gears. Again. She set down the drawing she had been studying. This world is held together by things you need to already have. It was not the first time we had met this problem. The lathe had been the first time. You need a flat surface to make a flat surface. You need a straight edge to make a straight edge. You need a screw to cut a screw. The three-plate method had broken that loop for surfaces. The bootstrap for the lead screw had been uglier. Start crude, use what you have, improve what you build with what you built. The same logic applied here. Baek Tae-ho had been listening from the corner where he was reviewing the metallurgical notes on the hob material. He did not look up. It pulls itself up by its own teeth, he said. I've stopped being surprised. I've started enjoying it. He said it with the particular calm of a man who has been surprised enough times that surprise has cured itself. I had noticed this change in him over the past months. In the early days of the forge work, each new paradox had visibly unsettled him. The idea that you could not get to precision without already having precision had struck him as a kind of cosmic injustice. Now he seemed to find it almost elegant. The bootstrap was the method. Start with crude change gears, good enough to run a first hobbing pass. Feed the output of that first pass, better gears, more consistent than anything we could cut by indexing, back into the machine as improved change gears. Run a second pass, feed those back. The hobber would improve itself with its own product, pulling its accuracy up by the teeth of its own making. It would take iterations. Everything took iterations. That was not a problem. That was the process. We built the hobber from everything we had accumulated. The bed came from the planed and scraped cast iron we had been producing since the foundry improvements, flat to within what our surface plates could certify. The spindles ran in bronze bearings that Mok Jae had fitted by hand, scraping the bores until the journals turned without detectable play. The feed mechanism borrowed the lead screw logic we had developed for the lathe, translated into the slower, heavier register that hobbing required. And Cho Yeong scraped it. She scraped the critical mating surfaces of the hobber, the way she scraped everything, methodically, without visible impatience, working the blue-marked high spots down with a hand scraper until the contact pattern spread even across the full face. But she went further on the hobber than I had seen her go on anything else. She scraped past the point where her own hands could feel the remaining error, working from the surface plate readings alone, trusting the measurement over her sense of touch. If the hobber lies, she said, not pausing in her work, every gear it cuts lies. I'm scraping past where even I can feel. I watched her work for a while without speaking. There was nothing to add. She understood the stakes as well as I did, better perhaps, in the tactile register that was her particular intelligence. A lie in the hobber's geometry would propagate into every gear the machine ever produced, and those gears would propagate it further into every machine they drove. The error would compound through the whole chain of capability we were trying to build. She was scraping it out at the source, at the cost of working blind, guided only by the plate and the numbers. That was the right method. I did not tell her so. She knew. Mok Jae made the hob. The hob is the heart of the hobber, the cutter that carries the tooth form, that transfers the involute into every blank it touches. Making it was the most demanding single piece of tool-making we had attempted. Mok spent 4 days on it, forging the blank from the best tool steel Bechtel could produce, turning it to dimension on the lathe, cutting the helical thread form, gashing the flutes across the threads to create the cutting edges, hardening the whole assembly, then grinding the cutting faces back to geometry after hardening had moved them. He brought it to the bench when it was finished and set it down without ceremony. It was a compact, dense thing, shorter than your hand, the helical thread gleaming where the ground faces caught the lamplight, the flutes running across it at their precise angle. The shape of the gear's teeth lives in the shape of this cutter, he said. He looked at it for a moment. No pressure, only every machine will ever build. He said it dryly, but he did not pick it up again carelessly. He wrapped it in oiled cloth and set it in the fitted case he had made for it. The first hobbing run was on a blank we had turned from the best iron we had, a wheel perhaps 2 handspans across, face true on the lathe, bored to fit the arbor. We mounted it on the hobber, set the change gears for the tooth count we wanted, checked the hob engagement angle, and started the machine. The hob turned, the blank turned with it, driven through the change gear train, the 2 motions locked together in their prescribed ratio. The hob fed slowly across the face of the blank. Chips, fine, bright curls of iron, flowed away from the cutting zone and fell to the tray below. Mok Jae stood at the side of the machine and watched. He did not speak. His expression was the one he wore when he was seeing something he had not seen before, and was not yet ready to name. Later, when I asked him what he had been thinking, he was quiet for a moment. It's like watching the machine dream the gear into being, he said. I understood what he meant, even though it was not the kind of language I would have used. The teeth were not being made one at a time, each a separate act of will. They were emerging all at once from the continuous motion, as if the gear had always existed inside the blank, and the hob was simply revealing it. The form was in the synchronized motion, not in any single cut. When the run finished and we lifted the blank from the arbor, the teeth were there, 40 of them, running clean around the circumference, the involute flanks catching the light in their characteristic curve. Seo-rin measured them. She had been waiting for this. She had her gauges laid out on the inspection bench before the blank had finished cooling. The tooth thickness gauge, the span measurement wires, the comparator she had been calibrating for this specific purpose. She worked through the blank methodically, measuring each tooth, recording each number in the log she kept for every critical component that passed through the workshop. When she was done, she stood back and looked at the numbers. "Every tooth identical," she said, "which no hand can do." She paused. I waited. "There's still error, but now I can measure exactly how small, and how to chase it." The error was real. The change gears we had used for this first run were the best we had been able to produce by indexing. Good, by the standards of what we had been able to do before the hobber existed, but not good enough to make the hobber's own synchronization perfect. The error in those change gears had printed itself into the spacing of the new teeth, subtly, measurably, but consistently. Every tooth was wrong by the same amount in the same direction, which meant the error was systematic, which meant it could be corrected. "Feed these gears back in and cut the next truer," I said. "The hobber will perfect itself." Seo-rin was already writing in her log. She nodded without looking up. She had understood the plan before I said it. She had been measuring toward it. What she had now was not just a gear, it was a quantified error, a known deviation with a known cause, and a clear path to eliminating it in the next iteration. That was what measurement gave you. Not the comfort of thinking you were right, but the precision of knowing exactly how wrong you were and in which direction. We stood in the workshop as the lamps burned low, the hobber gleaming at the center of the bench, the first true gears laid beside it on the inspection cloth. Baek-tae-ho had come back in from the metallurgy room and was looking at the gears with the expression he had been wearing more often lately. Not quite satisfaction, but something adjacent to it. The look of a man who has watched enough impossible things become possible that he has revised his estimate of what is possible. There was still a wall ahead of us. I had been thinking about it all day, through the scraping and the hob grinding, and the first run, and the measurement. The hobber was built, the bootstrap was running. The gears would improve with each iteration, and the machines those gears drove would improve with them. But engine-grade quality, the precision that a working steam engine demanded from its valve gear, its governor, its crankshaft, required more than accurate teeth. It required the ability to calculate gear trains for any ratio, to lay out compound trains that could drive a governor spindle at exactly the right fraction of the engine speed, to design the tooth geometry for specific load and speed conditions. The hobber was the loom. We still needed the weaver who could read the pattern. "We built the loom," I said. "We still need the weaver who can read the pattern." Itaho picked up one of the gears and turned it in his hands, feeling the teeth with his thumb. "Now we just need this mad geometer to be everything Seo-rin hopes," he said. I thought about what Seo-rin had told me about the woman she had in mind, the one she had been trying to bring to the workshop for the past month, who apparently thought in gear ratios the way other people thought in words, who had been calculating compound trains in her head for purposes that had never had any practical application, because no one around her had ever built anything that needed them. Mad was one word for it. It was not the word I would have chosen. "If she really thinks in these curves," I said, "she's not mad. She's been waiting for a world that needs what she knows." Baek-tae-ho set the gear back down on the inspection cloth, carefully, teeth up. Outside, the veil cast its pale light across the ridge, thinner than it had been a year ago. I could see that even without measuring it, though Seo-rin measured it too, logged it in the same careful hand she used for tooth thickness and surface flatness. The dome of light that had protected Iron Ridge for generations was failing by increments, and the only answer we had was to build fast enough that when it was gone, what we had built would stand in its place. The hobber sat on its bench, first gears beside it, waiting for the next iteration. The bootstrap was running. The loom was ready. We needed the weaver,